Today I'm talking about LeetCode problem 1545, find kth bit in nth binary string. What this problem asks you to do is to compute what they call a binary string, a string of zeros and ones, and then to find the kth bit in that binary string. So they may want you to find the first, second, third, whatever bit in their binary string. They give you a rule to compute the binary string, and the rule is a kind of recursive definition. It says for s of 1, the binary string is just 0. For s of I, the binary string is s of I minus 1 concatenated to a 1 concatenated to a reverse of the inverse of s of I minus 1. So inverse is just replacing any 0 with a 1 and any 1 with a 0, and reverse is just reversing the binary string. So you can kind of see how this recursive definition would break down any value greater than 1. So s of 2 is s of 1 concatenated with a 1 concatenated with a reverse of the inverse of s of 1, or 1, 0, 1, 1. So this is the rule on how you produce the binary strings, and then they just want you to find the kth bit of it. So in this example, the first bit is 0, the second bit is 1, the third bit is 1, and so on. So I was honestly a bit confused that this was ranked as a medium problem because it seems very simple to me. It seems very easy to me. They give you the formula for how to produce the binary string. So it's just a matter of producing the binary string and then returning the value at index k. So pretty straightforward. And then furthermore, n is constrained to be between 1 and 20. So it's not like you can have a huge n where it might be impossible or prohibitive to calculate what the binary string is. So in fact, I just solved this by calculating the binary string and then returning the kth bit of it. In my function find kth bit, I get the binary string for the input n, and then I return s of k minus 1. And k minus 1 is just because this problem is I suppose 1 indexed. So they mean 1 to refer to the first value in the string, as opposed to 0 index, which is how Python wants to access list indices. So let's look at the getString method. The getString method, I'll come back to this part in 1 second. The getString method first just defines the base case. If n is less than or equal to 1, return 0. That's the same definition here. And then it's going to find the previous string, which is the getString of n less 1. So that's finding the s of I minus 1 part. And what we do is we just return the concatenation of the previous string with a 1 with the inverse of the reverse of the previous string. And my inverse function is just going to go over the input string and it's going to build a new list using a 0 if the input value was 1, or a 1 if the input value was anything other than that. So just a 0 for each of the values in s, and then it's just going to return a string made from this list. So inverse is, pretty straightforward. And this : -1 notation will just reverse a string in Python. So it's pretty much exactly the formula they've laid out here. It's the previous string concatenated with a 1, concatenated with a reverse of the inverse of the previous string. And then, so this is related to what I was going to talk about in a minute. When I was originally writing this, I thought, well, maybe I'm going to call getString many times with the same input. And so what I did here is what you would call memoization. So in my solution object, I have a dictionary for my getStirs function. And what I'm going to do with that dictionary is just every time I call getStir, I'm going to put the arguments to getStir, the n, into my dictionary with the results of that call in the dictionary as the value. And the reason for that is I thought, well, maybe my solution is going to call getStir a lot with the same inputs. So maybe I'd call it with, getStir 5, getStir 4, getStir 3, And then the next time when I call getStir6, I'm going to call it getStir5, getStir4, getStir3. So I thought, well, there's no need to recalculate it every time. I'll just store the output values in a dictionary. But this wound up actually not doing anything to help my performance. I think it must be how to do with how LeetCode is constructing the solution objects and calling the find kth bit. I thought perhaps they'd construct one solution object and then call find kth bit many times, but it seems that they construct one new solution object every time they call find kth bit, so it doesn't really help my performance to do that. But yeah, this is a solution to it, and it's kind of average speed. It's something in the 50th or 60th percentile. So in some way I was disappointed because it seemed easy, and I just solved it kind of literally copying the problem statement. So I also spent some time thinking about, okay, well, how could I make it faster? I didn't bother to implement this because, well, it seems like an easy problem, and making it faster seems like it might be kind of a hassle or a bit of work, and I don't know that I wanted to do that. But I started to try to think, okay, well, how can I improve the speed? One idea I had would be using booleans, or a single bit instead of a string. So I suppose I'm hypothesizing here that it's more expensive to compare strings or string indices than it would be to compare booleans. So whenever I inverse the string, I'm doing a few string comparisons. And so I just hypothesized that, okay, if I was using booleans instead, maybe that would be faster to compare. And I suppose it would use less memory. Rather than the reverse string, I could iterate over the array and then backwards over it. So I just imagine this loop that goes through the range of double the array plus 1. And what it would do is, rather than concatenating the array to its reverse, you just say, okay, for every index in this range, double the length plus 1. If the index is less than the range, we're just going to get out an I from the array. If the index is equal to the length, so let me draw what I mean here. If we have 0, 1, 1, we're going to build up a result by saying we're going to go through 0 to 6, 0 to 6, and we're going to say, okay, here I points to 0, so I is less than length, so we're just going to get out a 0. When we iterate again, I will be 1. Iterate again, I is 1. Iterate again, I is exactly at length. I is 3, so it's pointing off the end of our list. And so there what we'll get is a 1 in this statement. And that's just to represent the 1 that we expect to be in the middle of our concatenated arrays. So recall that the problem wants you to have the previous string, a 1 in the middle, and then the inverse of the reverse of it. So this 1 in the middle is this 1 that we just put in here. And then otherwise, we would just go backwards over the array like this. So then we would just put in a 1 as we iterate backwards over the array, 1, 0, 1, 1, 0. And so writing a function to kind of incorporate this logic would let us do this line without doing a string reverse, which I'm going to assume is somewhat expensive. Probably more expensive than just iterating forward and backward over the array. And it would let us avoid the concatenation, which is creating new strings. So those things would probably be a little bit faster. One other idea I had for increasing the speed, I just copied and pasted this into my IDE editor here. And then I just essentially called my getString method to produce the bit string for the value 10. And what I'm doing is I'm saying, tell me what the bit is, or sorry, I'm getting the string. Well, I see. I have made a mistake there. This may not be as useful as I was saying. Okay, no, it's exactly the same. Anyway, I am getting the string I'm getting the string of length n for n between 2 and 10. And then what I'm printing is the size of n, and then the kth value of the first 3 indices. So what it's saying is, in a string of length 2, the 0 value is 0, 1 is 1, 2 is 1. And what this looks to me like, they're all the same, basically. So I guess it's kind of saying to me that the first half of the string doesn't change. Or half may be the wrong way to think about it, but the starting point of the string doesn't change. And that kind of makes sense because you're concatenating the previous string at the front every time. So if we just look at it here with the first 4, 0, it's always 0 every time. 1, it's always 1 every time. 1, it's always 1 every time. And that's going to hold true basically for all of it. For everything to the left of the 1 that you're inserting in the middle. I think that'll hold true. So this is kind of a long way of saying, I think there's a possible simplification where you just calculate the bit string until the length of the bit string exceeds k, at which point you can stop calculating and just return the answer. So those are a few ideas I had. I didn't bother to implement them. I think 50 to 60 percentile is already okay. And honestly, these ideas don't sound that fun to me. They sound a lot more like kind of fiddling with the code and getting something to work. I think they would have some promise for improving the performance and probably get above 60 percentile at least. But yeah, that'll do it for me for this problem. If you enjoyed this video, let me know by clicking the like button. If you want to see more LeetCode problems, I'm going to aim to try to solve one of these a day or so, maybe a little bit faster than that rate, and I'll upload explanations of them as I solve them. So yeah, let me know in the comments. Subscribe if you want to see that kind of thing. Otherwise, thanks for your time.